Welcome to the 2022 Revision Support for Learners for the National 5 Maths course. I'm Leah Payne and I'm a teacher at McLaren High School in Callander in Stirling, and I'm going to take you through some key points for the exam in May. The purpose of this session is to become familiar with the SQA guidance for the 2022 exam, to identify useful revision resources, and to consider top tips for exam success. By the end of the session, you'll be able to use the SQA guidance for the 2022 exam to help you plan your revision and to prepare for the exam itself. So the National 5 Maths exam, when is it? It's on Wednesday the 4th of May in the morning. Paper 1, non-calculator, will start around 9 o'clock, finishing around 10 o'clock. Paper 2, about half an hour later, starting at 10:30 and finishing around 12 o'clock. So the reason why I say it starts around these times is that different schools might have to have slightly different start and finishing times just to fit in with their school day. What will the paper itself look like? Well, paper 1 will be out of 40 marks, okay, and it's an hour long. Paper 2, your calculator one, a wee bit longer, an hour and a half, 1 hour 30 minutes, and it's worth 50 marks. So on the week beginning of the 7th of March, the SQA had released guidance on topics that would not be assessed in the 2022 National 5 Maths exam. So let's have a look at that just now. So the first 3 topics, okay, that are on this list, vectors, similarity, 3D coordinates, they were topics that were always out of being assessed. We knew about them at the beginning of August. Okay, so starting at point number 4 there, the SQA have told us that they will not be assessing rationalising the denominator of a fraction, using the law of indices, a to the power of m over n, okay, so fractional indices, and rewriting that in surd form to simplify expressions, right? So you might still get a index, which is a fraction, but you just won't be expected to change it to surd form to simplify it. Working with depreciation, expanding brackets of the form ax times bx plus c, where a, b, c and d are the set of real numbers. Factorising algebraic expressions using a combination of common factor, difference of p-squares and trinomials. Identifying the gradient and y-intercept from various forms of the equation of a straight line. Finding the graphical solution to simultaneous equations. Changing the subject of a formula involving a linear equation. Recognising and determining the equation of a quadratic function from its graph. Sketching a quadratic function of the form y equals k times x plus p all squared plus q. Identifying the equation of the axis of symmetry of a quadratic graph, using the discriminant, calculating the area of a sector, working with the graphs of trig functions involving a vertical translation and or a change in phase angle, using bearings to find a distance or direction, determining the equation of a best-fitting straight line on a scatter graph and using it to determine y given x, and finally comparing data sets using a calculated or determined interquartile range. So having a look at the SQA guidance in more detail, here's David Cleland from Cleland Maths on YouTube, who has broken down the course specification to give you a wee bit more detail about the whole of the National 5 Maths 2022 exam.
Mr. Cleland here from Cleland Maths. So today we're going to look at what has the SQA changed in National 5 Maths this year. There's been a massive document just came out last night, and you might have seen it yourself and you wonder, what does it all mean? Here's my take on it. So what let's look at numerical skills. Rationalise the denominators from such as out. Simplifying such as still in. If we look at laws of indices, we have got fractional indices are out, but the standard laws of indices, times and dividing, adding, subtracting are all in. Rounding to significant figures are still in. Let's look at the next thing. If we look at percentages, most of the percentages are still in. The only little change there is depreciation is out. So appreciation is in, but depreciation is out. Fractions is in. Fine. Algebraic skills, this is where it starts to get quite big. So working with algebraic expressions involving brackets, most of the expanded bracket stuff is in, except this one here, ax times bx plus c is out. I don't know why. Next one we've got is combinations of factorizing. So you'll still get asked to do all your factorizing, common factor, difference of two squares, trinomials, but you won't get asked to do a question with a combination of all them in at once. Reduced algebraic fractions in simplest form is still in. Applying the full operations to algebraic fractions, that's in too. Okay, straight line stuff. This is quite a big one as well. You will not be asked to identify the gradient and y-intercept from various forms of an equation of a straight line. What does that mean? It means that something like ax plus by equals 3. You will not be asked what the gradient and y-intercept is at that point. You still have to work out the gradient and y-intercept yourself from your own equations, just not from a given equation or graph. What else is out? Well, if we look at simultaneous equations, you'll still be asked to solve them, you'll still be asked to make them, but you won't be asked to do a graphical solution. You won't be asked about the point of intersection between two lines. Changing the subject of a formula. Well, you'll be asked to do ones involving a square or square root, and you won't be asked to do ones where it's just ax plus b equals c. So that's it. Let's move on. Let's look at our quadratics in more depth. So you'll be not be asked to recognize and determine the equation of a graph, a function from its graph. You will not be asked to sketch a quadratic function from completed square form. You will be not asked about the axis of symmetry. You will have to still solve a quadratic equation. You have to use the quadratic formula, and now this is where we get a little bit tricky. Using the discriminant to determine the roots. What the SQA said here was, you will not be asked to use the discriminant. That's a little bit unclear. So, in theory, you could be asked to work out the discriminant. You may even be asked to work out the nature of the roots. But you won't be asked to use the discriminant to work out, maybe say, a unknown quantity. So that's a little bit unclear. But I would say, err on the side of caution. If I've said using discriminants out, chances are I won't ask about the discriminant. So I would be happy enough to cross that one out with the, caveat that this is what the SQA say. Moving on. Geometric skills. So, determining a gradient of a straight line given 2 points, circle geometry. Let's look to see what's out here. Well, first thing is, calculating the area of a sector is gone. All this stuff on this page is already gone. We're never doing similarity, we're never doing vectors, so we just cross that out straight away. Trigonometric skills. So let's look at what we can do. Well, with graphs, we'll still be asked to do trigonometric graphs, but we won't be asked to do vertical translations. So that's when it's up or down, adding a number. Or we won't be asked to do ones where it moves left or right. So we can still be asked to do multiple graphs, or where it's stretched. And if we look further down the page, we will not be asked to find the distance or the direction using bearings. A big one there. Bearings is a topic that a lot of people struggle with. Okay, stats. Another contentious one, this. The SQA said you will not have to compare data sets using the interquartile range. What they did not say was you would not have to work out the interquartile range. Anyone on the side of caution, I would say interquartile range is out. You won't want to upset anyone, and chances are you won't ask you to find the interquartile range. I would cross that off with the caveat as before, what the SQA said. The last one, from the linear equation model, given a set of data, you'll not be asked to find the line of best fit from a scatter graph. So that is it. there's a little caveat there. It's possible, more likely, you could still be asked to calculate that quarter range. Okay, let's recap. What is in, we've just went out what's out, what is in National 5 Maths. The source for this is Data Maths Checklist, check it out, great site. So, rounding, decimal places, significant figures. We've got our surds, basic subplication, multiplication, division, addition and subtraction. We have got indices, all the laws of indices is normal except fractional indices. Standard form, to inform standard form, calculations of standard form, expanding double brackets where there's a 2 by 2 and then 3 terms, and then of course expanding and simplifying single brackets as well. Factorising, common factor, difference of two squares, trinomial, all trinomials, anything at all we could ask you with factorising, except we're not going to ask you to combine. So you'll not be asked a question about let's do a difference of two squares and then something else, or let's take a common factor and then a difference of two squares. That won't happen. Okay, you'll get asked to complete the square, not a problem. Simplifying algebraic fractions, multiplying, dividing, adding, subtracting, that's still in. Gradients, the gradient formula is in. Calculating the length of an arc of a circle is in. Maybe find the angle, the radius of a diameter will be in. All your volume stuff's in. Stuff about being able to find the equation of a straight line, find the gradient, find the y-intercept, using y minus b equals mx minus a, knowing the parallel lines have the same gradient. Basic function stuff is in. Solving equations with brackets, forming your own equations, solving equations with fractions, solving inequalities or inequations, that's all in. Solving linear simultaneous equations is in, either by substitution or by elimination. Changing the subject of a formula is in, as long as it's got a square or a square root. Quadratic graphs, knowing where the minimum and maximum turning point is and what it looks like. Solving them by factorising, quadratic formula, sketching quadratics if they're factorised already, and forming your own quadratic equation and solving them. As discussed with the next one, nature of the roots, probably out, but here is what may be in if it isn't at all. Angles and polygons and circles is in. Converse of Pythagoras, Pythagoras' theorem in circles is in. Using the distance formula, working with Pythagoras in 3 dimensions. Trigonometry, we've got trigonometric equations and identities, that is in. So we've got triangle trig using the sine rule, the cosine rule, and then percentages, appreciation is in, and reverse percentages is in. Fractions, all the standard fraction stuff is in, add, subtract, times, divide, mixed numbers. And with stats, again, the SQA said that comparing data using interquartile ranges out, but you can still be asked to find the interquartile range. So I've left that in, and also mean standard deviation is there as well. One last bonus. Here is an analysis of all the National 5 past papers from 2014. Everything in green you can do, anything crossed out you don't have to do, it's not in this year's exam.
Okay, so that was quite an extensive list from David Cleland there on Cleland Maths. You can watch the video again if you play this video, or you can check him out on other videos on YouTube as well. So at the end of his video, what he suggested was looking at past papers and identifying the current past papers that are out there and working out what is in and what is not in the assessment, okay, just to really help with your revision. So what we're going to look at now is an Excel sheet, which is a checklist of all the past papers, and we'll just take a wee look at that now. Okay, so this Excel sheet was a resource that's been shared by the staff at Wallace High School. Okay, and what has happened here is that all the past papers from 2019 to 2015 have been collated in this Excel sheet. Okay, so what you will see at the top there, the 2019 paper, they're all hyperlinked. okay, along with the solutions. So they're all in one place. You can just click on that and it'll take you to the website. The spreadsheet itself is very, very useful because it goes through and it tells you what topic each question covers, which each question, the topic it focuses on. And if we have a wee look at the 2019 paper question 5, question 6, it's been greyed out. And the reason why it's been greyed out is because the SQA have decided that that's not going to be assessed in this year's assessment. So there would be no point spending your revision time on that, okay? So these are past papers all the way up to 2019, starting from 2015. So the upper part of the spreadsheet is your non-calculator stuff, and the lower part is the calculator. So a really useful revision tool for you to be using, a handy wee checklist. If you kind of open it up, make your own copy, it'll save into your Google Drive, work through the questions, you can tick it once you've completed it, and it's just a really good way of knowing what you have completed and what you could still work on. So what we're going to do now is just spend a moment looking at some of these questions from these past papers. Okay, so the first question that we're going to look at 4 questions in total, and just have a wee look at how we'd answer these to SQA standard. So the first question that I've picked is from the paper 2. It's question 1 from the 2019 paper. Okay, so I'll let you read it. Okay, you can pause the video, you can try it for yourself, and then once you're done, hit play again and see if we come up with the same working and solution. Okay, so the solution is just as important as your working. Okay, so the two of them go in tandem there. So what we want to do is make sure that you are reading questions carefully. Okay, so this question says that a charity distributed 80,000 emergency packages during 2018. This number is expected to increase by 15% each year. So calculate how many emergency packages the charity expects to distribute in 2021. Okay, so what we have got is an appreciation question. Now remember, in the guidance that the SQA released a couple of weeks ago, they have said that depreciation is out. So you could probably pretty much guarantee that an appreciation question like this is going to be in, okay? So what we have to do is we have to understand that your new percentage value is going to be 115%, okay? Because it's increasing by 15% each year. So the new percentage value is 115%. Now, they tell you that the initial value is 80,000 in 2018. The question is asking how many by 2021. So you need to work out how many years, so 19, 20, 21. So you've got 3 years, so your power is 3. And then you're timesing by the initial value, which is 80,000. Now, this bit here, your percentage, right, it's a calculator paper. You should understand that you don't put in a percentage straight like that into your calculator. You have to get the decimal form. And to get the decimal form, you have to divide it by 100. Okay, so just the percentage bit. So what we'll actually be typing into the calculator is 1.15 cubed times 80,000. Okay, so what you've got to try and do is just set out your working, set out your solution before you even touch your calculator. And then once you're happy with that, you can pick up your calculator, type it in, and then see what answer we get. Okay, so what I've got is 121,670. So that's what you need to do to get your 3 marks there. Okay. Now, just be careful because sometimes they could change a question like this into a 4-mark question. They might ask you about rounding to significant figures, okay? If they ask you to round to 2 significant figures, you just have to think, well, that's my first one, that's my second one. So I've got 120,000, okay? And what we should really do is put on the units. So in this case, it is packages, right? Because we can be very particular about having the correct units on there. So in the red, that is to 2 significant figures, 2 sig figs, right? If the question asks you to round it to 3 significant figures, 1, 2, 3, your answer would be slightly different. It would be 122,000 packages, and that would be to 3 significant figures. Okay, so once you've completed that, what you could do is you could go back to your past paper spreadsheet, okay, and we looked at question number 1 on the 2019 paper. So it would just be a case of scrolling down there, tick it, I'm happy, I'm confident, I'm ready to go and look at a different topic. Okay, right, let's look at another question. So this one is from the 2019 paper 1 and it's question 4. So again, the SQA have said that area of sectors is out, right? So if they're going to put a circle question into the exam, then you could pretty much expect that it's going to be dealing with the length of the arcs, okay? So if we just take a moment to read this question, what we have got, okay, is the diagram below shows a sector of a circle, centre C. The radius of the circle is 30 centimetres. Calculate the length of the major arc AB. So first of all, you need to understand what it is they're actually asking you to work out. They want you to work out this bit here. Okay, so all the way from A round to B, so just the arc, okay? So not the perimeter of the shape, just the arc, so just the part of the circumference. So you have to go into your exam having memorised the formula for that. C equals x over 360 degrees times pi times the diameter. Okay, so get your formula, allow yourself time to think, get your formula written down, and then go on to your substitution line. So the x is to do with your angle size that's within the sector, and in this case it's 240, so 240 divided by 360 times by, right, because they have asked you to do this without a calculator, they've told you to take pi as being 3.14, okay, and then you want to times by the diameter. Now be careful here because the question has given you the radius, so just from the centre to the circumference. So you need to double that to get the diameter. So the diameter is 60. Okay. Now what makes this a difficult question is that you've got a fraction, you've got a decimal, and you've got timesing by a whole number. Okay. So what we're going to look at first is the fraction, and we're going to look at simplifying it. Now straight away we can see that that fraction can be divided by 10, so 24 over 36, okay, times by 3.14 times by 60. Okay, so we're simplifying this fraction. Some of you might be able to simplify that a lot quicker, right, but others might just have to do it in kind of mini stages there. Now hopefully you then see that 24 and 36 are both multiples of 12, so both can be divided by 12. So you've got 2/3 times 3.14 times by 60. Now the next difficult bit is to times a decimal, or to times by a decimal, so multiplying by that 3.14. So remember, it doesn't matter the order that you times in, okay? So you could do 2/3 of 3.14 first, or you could do 2/3 of 60 first. And that's the easier way to do it, because 2/3 of 60, well, 60 divided by 3 is 20, times by 2 is 40. So we're going to end up with 3.14 times 40. Okay, so we got 40 by finding 2/3 of 60. Okay, so then what we've got to do is to times 3.14 by 40, becomes a much easier question. 31.4 times 4, so I've multiplied it by 10 and I've still to times it by 4. Now, absolutely nothing wrong with just quickly writing out your 4 times table. Okay, sometimes it just helps to relax us a wee bit and to give us a wee bit of focus. Okay, so 4 4s, and I can see from here, 4 4s, 1, 2, 3, 4 is 16. So 6 carry over the 1. 4 1s is 4, add on the 1 is 5. 4 3s are 12, and that's your final answer, 125.6. And remember those units, and we can just underline to say, that's me, I'm done, I'm happy with my answer. Okay, you could then go back to your past paper Excel sheet. Okay, go back up to the non-calculator 2019. We've just completed arc length. Okay, right, let's look at a third question. So this is trig graphs. And this is taken from the 2018 paper 1, question 6 on there. Okay, so there was a wee bit in the guidance about what was going to be included in terms of the trig graphs. Okay, so they said that they were going to take out the phase angle. Okay, and that is the movement going left to right. You won't be assessed on that. And they've also taken out the vertical change, okay, the vertical translation, so the graph won't be moving up or down. But you could expect to get a graph that has been stretched, okay, or a graph that has been compressed, okay. So what this question is asking for 2 marks is to state the values of A and B. So where are A and B? Well, A and B are in the equation for cos. Now you know it's a cosine graph because it starts up high, okay, so you should be confident with the basic shapes of your cosine graph, okay, and likewise you should be okay with the basic shape of your sine graph, okay, so I'll probably just revise that as well, the basic shape of your sine graph along with the basic shape of the cosine graph. Now your value for A is to do with this bit here, okay? So it's called your amplitude. Now, really what you should be doing is looking at your high number, your low number, working out the total space between them, which is 10, half of that is 5, okay? But in an exam, all you need to do is just say, right, what's my top number, what's my bottom number? If they're the same number, one's positive, one's negative, then that is your value for A, okay? So it's just 5 there. Now, your value for B, that is to do with how many cycles of the cosine graph you have got between 0 and 360, okay? So if it was just one cosine graph, okay, a normal cosine graph, that is what it would look like between 0 and 360, okay? So basically you just want to know how many of that shape you've got in front of you. So when we start to trace it, there's one whole graph and there is a second graph, right? But be careful because your answer's not 2. Because remember what I said, your value for B is how many graphs between 0 and 360. This is only showing the graph between 0 and 180. So remember that the graph could just continue on, right? So how many between 0 and 360? Well, if there's 2 between 0 and 180, then there is going to be 4 between 0 and 360. So that is your solutions for this question. Okay, so again, you would just go back to your Excel sheet. I was on the 2018 paper 1, trig graphs. There we go. I'm just going to put in a wee tick there. I've completed it. I feel good about it. Right, last question that we're going to look at on this, okay, is going to be a standard deviation question. Okay, so this is from the 2018 paper 2. It is question 5 in there. And if I just zoom in, so what we've got is a farmer's market took place one weekend. Okay, so stallholders were asked to record the number of customers who visited their stall. So the number of customers who visited 6 of the stalls on Saturday were as follows. So you've got your list of customers there. Okay, calculate the mean and standard deviation of the number of customers. So they're asking you for 2 things here. First of all, they're asking you for the mean. Now, the mean should be straightforward, okay? What we're doing for the mean is we're just adding them all up, okay? So take your calculator to hand. You've got 120 plus 126 plus 125 plus 131 plus 130 plus 124, okay? So when I've added all them up, I get 756. Now, a good idea just to chuck all those numbers back into your calculator, okay, so add them up for a second time, just to make sure that it was 756 that you got, okay? If it wasn't, check it a third time and see what you get, okay, because you want to make sure that you're making no mistakes for questions like this. Now, we're then dividing by 6, because that's how many we had added up all together. And 756 divided by 6, we get 126. Now remember your units, so we're talking about customers. So the mean is not just a number, the mean tells us that the average customers is 126, okay, over those stalls. Now the next bit that we want to work out is the standard deviation. Now there are 2 formulas to learn, or not even to learn, there's 2 formulas for standard deviation, okay? You just need to pick one of them. One that some people quite like to use just for its quickness is the kind of longer one, okay? So the standard deviation is the sum of x squared, take away the sum of x all squared, divided by n, all over n minus 1, and then take the square root of all of that, okay? But you obviously need to know what the notation is about, so we need to know what they mean by the sum of x, okay? Well, the sum of x is just the sum of all your numbers, which we know to be 756, okay? Which is different from the sum of x squared, okay? So what the sum of x is just the sum of all your numbers, but the sum of x squared is the sum of all the numbers but squared, okay? So you're squaring and adding all those numbers. So to work out the sum of x squared, you have to square and add, okay? So you're just taking all of those numbers and you're squaring and adding those together. All right, so again, it's just picking up your calculator and you're saying 120 squared plus 126 squared plus 125 squared plus 131 squared plus 130 squared plus 124 squared. Okay, and the answer that I get for that is 95,338. Okay, so I'm just going to double check that again. 120 squared plus 126 squared plus 125 squared plus 131 squared plus 130 squared plus 124 squared. Okay, so just get into the habit of double checking so that you're not making mistakes on questions like this. So we're now ready to substitute into our formula. They want the sum of x squared, so it's 95,338. We're taking away the sum of x, but they want us to square it, and they want us to divide it by n. Now, n is just how many numbers are in your data set. So we've got 6 numbers, so we're dividing that by 6. And then all of that top line is going to be divided by n minus 1, so we're dividing by 5, and then we're taking the square root. Okay? So then what we do is type the top line into our calculator. You can just type it in one go, so 95,338. Take away 756 squared divided by 6. Okay, so you get 82. So 82 for that top line divided by 5, and then the square root of all of that. So the key is not to put too much into your calculator in one go. So if I divide that by 5, I get the square root of 16.4, and the square root of 16.4 is going to give me 4.0496 ... And then just double check that the question doesn't want you to round it to anything. No, it doesn't. So the standard deviation is 4.0 customers. Okay, so that's how we'd finish off that question. Okay, now there's always a part B to these questions, all right, and they can be a little bit more trickier to answer. Okay, so if we have a wee look at part B, it says that the mean number of customers who visited these 6 stalls on Sunday was 117, and the standard deviation was 6.2. Make 2 valid comments comparing the number of customers who visited these stalls on Saturday and Sunday. So part A was about our values for Saturday. So when it says to make 2 valid comparisons, we have to make a comparison first about the mean. So what we say is that since 117, okay, and we go back and we have a look at the mean for our Saturday values, and it was 126. So since 117 is less than 126, on average, so you've got to use that 2 words there, on average, less customers visited the stalls on Sunday, right? Now your wording on that depends on how you write it. You might say on average more customers visited the stalls on Saturday, right? You've just got to get the day and the more or the less word used correctly together. Okay, so all of that is worth 1 mark, and it's really important that for the mean you are using the term on average, and that you do have your mathematical justification, as well as saying less or more on whatever day or team. Sometimes you get team A or team B. All right, or sometimes you get before a fitness program and after a fitness program, those kind of questions. Now, the second statement, the second mark, comes from making a statement about your standard deviation. So what we say is that since 6.2 is greater than 4.0, the visitors to the stalls on Sunday were less consistent. Okay, so it just means that there was more variation, okay, in the numbers who were visiting the stalls on the Sunday. Okay, they were more consistent for the Saturday because your standard deviation is lower. So a lower standard deviation means that data set is more consistent, it's more reliable, but a larger standard deviation means that you've got a less reliable data set and your values are less consistent. Okay, and then again, you would just go back to your sheet and you would have a wee look at standard deviation, question 5, tick that, done, I'm finished. I'm feeling quite good about that question. Okay. Another great resource that David Cleland spoke about in his video was the Zeta Mass checklist for National 5. Okay, so it might be a good idea to download this. You'll get this from either the link within this PowerPoint, okay, or you can go onto the Zeta website yourself, download it, okay, print it off, and then you can just use it to assess how well you know these things. Okay, so there's a lot of stuff on there. There will be an awful lot of stuff that you're really, really confident with. Okay, so maybe think about prioritising with the things, with the topics that you are less confident with. Okay, and maybe dip into the past papers, look at the marking schemes, really get in to see how the marks are awarded for that. Okay, so that is the Zeta Maths National 5 checklist. It's free to download, free to print off, and a valuable resource for your revision. We're almost at the end of this session, so I would just also like to draw your attention to the formulae sheet that you get for your final exam. Remember to use it, remember to refer back to it. Okay, it is helpful, even if it just allows you to collect your thoughts. Go back and look at it, even if you think that you know, for example, or you feel that you know the standard deviation formula off by heart. Just take the time to go back and make sure that you have copied it down correctly. The same with using the quadratic formula at the top there. Make sure that you've got all your negatives or your plus or your minuses in the correct places. Okay, so use the formula sheet to help you. One of a big mistake that people make all the time is the volume of the sphere one. Okay, they memorise it rather than looking at it on the day, and they get the fraction wrong. You can see there that the fraction is 4/3, and a lot of people incorrectly write down 3/4, okay? Or sometimes they incorrectly write r squared instead of r cubed. So it is important that you go back, you look at the formulas that you're using and make sure that you're using them correctly. Just another wee hint that if they give you any cylinders, okay, the cylinder formula is actually given there, it's hidden, okay? I know that this is the volume of a cone, but the cylinder is just the bit without the third, it's just the pi r squared h, okay? So if you remember that, then you're winning as well, okay? Because sometimes people forget about that. But there is obviously some formulas that you need to go in having revised. You need to remember your gradient formula, your y equals mx plus c, your y minus b equals m times x minus a. Okay, you're going to have to remember your appreciation formula, how to work that out. You're also going to have to remember the arc length formula, the c equals x over 360 pi d. Okay, so do not forget about the formula sheet at the end, it's there to help. Okay, right, exam top tips then. So just to kind of finish off, make sure that you are revising regularly from now until the 4th of May, okay? Don't leave it to last minute, don't cram it in, right? Maths isn't going to be the only subject that you're revising for, okay? So take the time to make a good revision schedule, prioritise your time. Okay, use the past paper checklist that I've spoken about in here. It's a really invaluable tool, right? And it just gives you something to focus on. Doesn't matter if you have done the past papers a million times before. Do them again, see if you can answer them from memory rather than looking back in your jotters. It's fine to look back in your jotters, but you eventually want to get to the stage that you can answer them without looking back in your jotters. Get to know the marking schemes. Okay, so the marking schemes are all hyperlinked within that checklist as well, that Excel checklist. Okay, remember that solutions, final answers are only worth 1 mark. Okay, it's all your working before your final answers that is worth the majority of the marks. So make sure you are providing a lot of detail in your solutions. You could maybe time your solutions, okay? So as I said, if it's maybe the second, the third, the fourth time that you're doing a particular past paper question, maybe get your phones out, set your timer, see how long it is taking you to answer a question. Out with kind of exam pressure, you could probably give yourself a minute a mark, okay? You might answer it less, you might answer it a wee bit more, but it just gives you an indication of how long you need to spend on particular types of questions. Read questions carefully, okay? Don't go in and just look for numbers and close your eyes and hope for the best. Make sure you are reading them carefully. You might have to read them twice, you might have to read them 3 times. Go back and read them after you think you've finished answering the question. Practice your presentation, okay? So if you're aware that your presentation is a wee bit messy, a wee bit scrappy, then take the time now to tidy that up a bit. Make a real conscious effort to really smarten up your writing. Okay, make sure that your 2s are 2s, make sure that your 7s don't look like 4s, make sure that your 1s don't look like 7s, make sure that your 0s don't look like 9s, etc, etc. Okay, because if your marker can't read your writing, then they might down mark you, thinking that you have written something else, okay? Ask questions, right? That's what your teachers are there for, okay? You might have brothers and sisters who have went through the course before. Ask people in your class, okay, or in a different class. Talking through questions, talking through solutions can sometimes help to really cement your understanding, okay? And importantly, take breaks, all right? We're not expecting you to be revising 24/7, okay? But we do want you to get into good revision habits, all right? So just to quickly run through resources from this that you can dip into, the links will be shared with you. There's the N5 past paper checklist. There's also the ZTAT Maths National 5 checklist. And then there is this Jamboard that we were working on tonight. Okay, so keep working away and good luck.